Discovery of ancient plant fossils in Washington points to Paelobotanic mystery. This is by University of Kansas. And we have here an exposed rock showing top-down view of fruit with an annular nectary, one entire wing and a partial wing, and three A-branded wings narrows. Now, new description of two well-preserved ancient fossil plant specimens in Washington state, is prompting paleobotanists to rethink how plants might have been dispersed during the late Cretaceous between 66 million and 100 million years ago. Now, we know 66 million years ago, we had the comet impact that did away with the dinosaurs. In the Yucatan Peninsula was the impact. Now, research published in New Phytology details two fossil winged fruits from the genus Ceratopetalum, previously believed to be limited in range to southern hemisphere during the Cretaceous. So that means that in Washington state, we must have had a very, very temperate climate. Now, during the Cretaceous, yet these new fossils were found on Sucia Island in Washington state. The surprising discovery is causing paleobotanists to reconsider how extended their range might have truly been and how it may have occurred. They said, in this paper we're looking at two fossil fruits we had assigned to the genus Ceratopetalum, which is in the flowering plant family Cunoniaceae. And the lead author, Keana Tang, doctoral student in ecology and evolutionary biology, University of Kansas, and KU Biodiversity Institute, Natural History Museum. And she said both the family Cunoniaceae and the genus Ceratopetalum still have living members today. What's interesting is in the genus Ceratopetalum is now only found in Australia. Well, the entire family is restricted to the southern hemisphere. So it's weird to find this fossil all the way up here in the northern hemisphere. We thought, wow, how did this get up here? Tang and her collaborators dubbed the new fossil species Ceratopetalum suciensis after the island in Washington where they were discovered. Today, modern versions of the genus Ceratopetalum prevail in the wet tropical rainforests of Australia, where they play a vital role to ecosystems. Tang said you'll find forests that are just dominated by these species. But she said the findings are made more significant because Ceratopetalum and the larger family Cunoniaceae are part of the Paleo-Antarctic rainforest lineages, or PARLs. They're plants thought to have originated in the ancient Gondwana landmass before spreading northwards. So a better understanding of how Ceratopetalum extended its range could better inform scientists how a key larger group of plants widened its range through geologic time. Well, maybe it's because the temperature and the ecosystems around the world were different at that time. Let's remember that before the flood, there were no rainbows. Something weird had happened to the earth and the sun's intensity. Anyway, going back to this, they have a joint history. They were where they were likely around Antarctica and spread northward as time progressed and tectonic plates changed, causing the climate to change. As Antarctica is getting colder, these plants are moving up to South America, South Africa, and Australia, Tang said. She said it's interesting because the Paleo-Antarctic rainforest lineages are all expected to have a southern origin. And now that we have this record of a fruit in the northern hemisphere, it's bringing up new questions. Was the family Cunoniaceae actually cosmopolitan? Were they found everywhere? Or was this just kind of a lucky chance where it somehow transported northwards through an exchange from the Antarctic to South America to North America? Well, the question should be, was the world's climate different? Anyway, according to Tang, KU advisor and co-author Brian Atkinson, assistant professor of ecology and evolutionary biology and curator with the Biodiversity Institute Division of Paelobotany, the findings highlight new possibilities for a biotic exchange between North America and South America, Antarctica, that may have occurred during the late Cretaceous. He said, in some ways, this is like finding a penguin in North America. The Ceratopetulum susiensis fossils were collected on Susia Island by fossil hunters David Starr and Jim Gotert, then micro-CT scanned at the University of Michigan by co-author Selena Smith. Then, to classify them with the utmost accuracy, Tang analyzed them layer by layer using a painstaking process called the cellulose acetate peeling technique. She said, I started peeling the rock. Essentially, what's happening is you take a rock face, and there's a series of steps where you polish the face of the fossil and dip it in 5% hydrochloric acid for a couple of seconds. It's very safe. You can even dip your hands in this acid, and you will still have your fingertips. Thank goodness. Now, so you dip it into the acid for a few seconds, and then you rinse the rock off with water. Then you rinse it with acetone, and you get this plastic sheet. That's the cellulose acetate sheet. And next you spray the fossil face with the acetone again, and then lay the sheet down. And that entire process gives you a very, very thin section of rock, a few micrometers. But it's nice because you can go through the entire fossil and pick up different structures hiding in the rock matrix you might miss in a micro-CT scan. Through these processes, Tang was able to place the fossils in the genus Ceratopetulum and raise new questions about how plants spread millions of years ago. Additionally, the research suggests the Pacific Northwest, where Ceratopetulum susiensis was discovered, is a promising region for further work by paleobotanists. Tang said, there's just so much to look into, especially in the western coast of North America. I understand there's just not a lot of people there doing that kind of work. It's relatively understudied. I think a lot of paleobotanic world has been situated along the east coast or the west interior. The paper in New Phytologist represents Tang's first authorship on the study in a peer-reviewed journal, and her first time as a lead author. She grew up in the suburbs north of Los Angeles and came to KU after meeting Atkinson and learning about his work when she was an intern at the Natural History Museum of Los Angeles. Once Tang earns her doctorate, her ambition is to continue making discoveries as a researcher. She said, would like ideally to work in a museum setting. And if I were her, I would do the same thing. This is by University of Kansas on phys.org. I think this is a fantastic find. It shows that it was most probable that the Northern Hemisphere had a similar climate to the Southern Hemisphere, and that's why they had similar plants growing there. Because as we know, these plants could not grow in other than a similar southern tropical rainforest type of setting. So again, something happened to the world before the flood that even changed the intensity of the sun and the climate. And of course, after that, we know that we had rainbows. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.